Welcome to our session. We'll look at the concept of the least costs and our ISO costs. So what are ISO costs? ISO costs are lines that show different combinations of inputs like labor and capital that a firm can buy with a fixed amount. It's like a budget. So that's what ISO costs are. So they are lines that show combinations of input for which you can buy an item given a fixed amount. So ISO cost will look something like this. Okay, they look like a budget in every day. For instance, a company has a 1,000 to spend on 2 units of labor. Okay, so the concept simply looks like that. So all combinations that lie on the same ISO cost will have the same total cost. On the other hand, we have what we call a least combination. It helps us find the cheapest mix of inputs of labor and capital that will give a certain level of output. So the concept here is that um, firms want to produce more while spending less. So we need to identify a combination that will compare the ISO cost with the combination that will give them the lowest cost whilst achieving a higher output. So this is the concept we want to look at in here. So we've been given different combinations in these questions, x1 and x2, all right? Where we have 1, 2, 3, up to 8, and their cost combination there. So we want to calculate and see the combination that gives us the less cost objective when the price factors are put. This is about 10 marks. So what do we do in this question first? What do we do in this question before we go in depth? So we need to come up with the price sets. So we're given case 1, where the price of good 1, we can call that PX, is 6.0. Okay, so the price for good 1, we have PX1 6.0, PX2 8.0. So the total cost function is simply we add the two costs. Then we have our good 2. Here we're given good 2. So here the price in case number 2 of good 2 0.85 and good 1 is 0.25. So I want to see which of these ones will give us the lowest cost combination. Okay, so I need you to follow me very closely. So we're going to come up with objective functions that will help us understand the cost combination. So we have two cases here, case 1 and case 2. So for case 1, we're going to make what? A cost combination, the total cost when we combine them. So PX1, so the total cost must have two components, okay? For good 1 and good 2. So PX1 and PX2, so we have 640 X1 and 8.00 X2. So this is the total cost in our first case 1. Our second case, PX1 is 0.75, PX2 is 0.25. So the total cost here will be 0.75 plus 0.25 X2. So we have these two cost functions. So we want to know, assuming uh, this is our X1 and this is our X2. So we want to know which combination will give us what? The lowest cost possible of our total cost if we're going to combine them. All right. So our function for our case 1, our total cost here is what? 6.4 x1 plus 8 x2. And here our total cost is given by 0.75 x1 plus 0.25 x2. So I want to see the values of good 1 and good 2 that will give us the lowest cost possible. So we can come up with a table that will help us identify the lowest cost that we're going to get from each case. All right. So in case 1, using that total cost function, we can evaluate the values of x1 and x2 to see what the lowest cost will be. So I can come up with a table like this. So based on case 1, we'll fuse in values here. Okay, so x1, 2, 3, 4, 5. Okay. So we're going to fuse them in here. Remember, we've been given values to guide us in our scale that will fit in the combinations. All right. So x1 and x2. So when we're going to fuse in these values here, if we're going to put a 2, then here we're going to put a 5, we're going to get 52. Point B, we get these coordinates 3, 4, we fuse them in there, we're going to get what? 51 here, 49 here, 48 here, 46, okay? So the idea here is we are looking for which combination will give us the lowest what? The lowest cost. We do the same with our second case value. We put in those values and we want to see which one will give us our lowest cost. Are we together? Are we following? So these are the figures we have here. Okay, so even here, we can use some figures to fuse in to find the combination. So it's giving us 2.7, 3.25, and so on and so forth. So those figures that we have there. So we want to see of these combinations for cost 1, you can see the last was the highest combination, was the lowest combination, point E, and this one, point A, is giving us the lowest combination. So if you're going to identify the combinations that are giving us the lowest, so at point A, where we had the coordinates, they gave us what? 2.75 for the second case. And for the first case, we found 46.4, which was giving us our lowest what? Our lowest cost combination. So in this case, we scrutinize each combination to get the cost structures. So these combinations are point A.
Ya chukua talk time. So na tena na che. On send the Panama exhibit moto for mumbo exhibit.
So our conclusion, therefore, would be that under case 1, the least cost combination is at E, where we got what? 46.4. Under case 1, the least combination is at point A, where we got 2.5. Okay, so we have 2 points. Okay, so you're choosing the values from here that are attainable. So we have discovered which combinations will give us a cost that will be lowest. Okay. Are we together? So this is how the input combinations will look like. So in our coordinates, we can say for case 1, to get 46.4, we had combinations of 6 and 1. In case 2, the combinations that gave us the lowest cost combination, we had 2, 5. So this combination is what gave us the least cost. So for case 1, our least cost was 46.4 under 6.1. Okay, where x1 was 6 and x2 was 1. Then case 2, we had 2.75 for the price of x1 and x2 under the combinations of 2.5. So if we're going to show those costs, although we're not told to do so, I'm just trying to illustrate that uh, we had 2.5, 2.5. So this was x1, this was x2. This was our total cost, which had what? 6.4 x1 plus 0.25 x2. Then the other one had 1.6, so 1 here and 6 there. So here our total cost was what? Our total cost 1.6. This one was 6.4 x1 plus 8 x2, where the total cost here gave us what? For the 6.4. Okay, so here it was 0.75. And our total cost gave us what? 2.7. So these are the combinations that will give us the lowest cost possible. So this is how this question was supposed to be answered. So take note that the combinations are coming from the list of what has been given. So 6.1 and 2.5 and 2.5. Okay. So these are the combinations. Okay. The first one was at 2, we had 6.1. So under this combination, 6 and 1, this was for uh, giving us our combination, which gave us uh, a total cost of 46.4. And the other combination was 2.5, which gave us 2.5, 2.75, 2.5, 2.5, which gave us what? 2.75. So this is the concept that we have in here. Okay, so let's go to our next question to do with our regression analysis. So we're given the following output table. So regression is basically used to find a relationship that exists between two variables. So this is a statistical output that is important for you to analyze. In the eyes of a statistician, you need to learn how to um, decipher that information. So we are told that a local gin producer engaged an economist who estimated the demand for alcohol beverage in Lusaka and Copper Belt provinces. So based on the drink's apparent success, the company is considering nationwide launch. So the company intends to use estimation guide in the selling prices and forecasting future demand. So the data for the observations of 48 covered quantity demanded, the number of drinks purchased per week. Competitors' average price per drink, income, and population is shown in the regression table there. So we have the constant, the on price, competitors' price, income, and population. So with those variables here, we now need to identify which ones are the what? Explanatory variables, and which ones are the dependent variables, the order. Okay, so we also need to understand the statistical significance of that table. Okay. Okay, so before I go any further, I'll just briefly give you some simple notes that you need to understand when you're dealing with the tables like that. So when you have a regression table, we have what we call the coefficients. What are coefficients? The term coefficient, what does it mean? It means what? A variable uh, which expresses the effect it has on the demand. So we have the coefficient, which shows the effect of each variable on the demand, how much it increases or decreases. That's the coefficient. So we have the standard error, which tells us how precise the coefficient is smaller or it is bigger. So that's standard error. If it's small, means the error is small. It's more reliable. If the standard error is big, meaning you have a lot of errors. And we also have the mean, which gives you the average value of each variable of data. Then we have the t-value, which is used to test whether there's statistical significance in those values. Okay, so we should also understand that when you're dealing with the t-value, it's calculated by the coefficient over the standard error. So we'll be comparing them with the t-values. Okay, so I don't know how much regression you've done, but I'm trying to simplify this so that we don't really have an issue with understanding the results. So regression basically talks about what? The relationship that exists between two variables. We have the dependent variables and the independent variables. So regression is used to basically study the relationship between one dependent variable, what you want to explain, and another variable, which we call the independent variable, the factors that will influence it. For instance, you want to explain how demand is affected by a rising income or price or population. So that is called regression. So it has a table which you usually produce under SPSS. So those tables are important parts in interpreting the regression. Like I said, we have what we call the coefficient. The coefficient is what? The constant part. Okay? So from our regression, we know that regression can be given by a plus bx. Okay? Or y is equal to b0 plus b1 x1 plus b2 x2. Okay. So if you have a table like this where the constant maybe is 10, okay, you can have a constant maybe 10, bx1 is 0.2, x2 maybe is negative 0.5. So using this formula that we've used, the regression table, the constant is the value that doesn't have a letter. It's the one that measures the impact of the independent variable. So here, regression equation based on this one here, we got 10 plus 0.2 x1 minus 0.5 x2. So we're just using these variables here to come up with the regression equation. So this one is a constant which measures the impact of each independent variable on the dependent variable. Okay, so this is that. Then we have what we call R squared, which tells you how much the model explains the variation in the independent variable. So if our R squared in here is, for instance, 0.8 1. It means 80%, 81% of X affects Y. So if your X is advertising and Y is your sales, it just simply means that of the sales that we have, 81% is because we advertised. Are we together? Are we together?
Yes, yes.
So I'm trying to take my time so to understand what is coming. Then if your error is simply 0.9, the error simply shows you whether the relationship is a positive or it's a negative. So it will tell you that the relationship you have between X and Y is a positive relationship. So error simply tells you whether the relationship is positive or negative. And we're going to look at the p-value. The p-value are there to help you to check the significance of your tests. Okay? So we'll tell you, we're going to compare them against the figures you're going to be given. So there's also what we call the t calculated. The t calculated is used to estimate how significant your values are. So it is given by coefficient over standard error. Of course, the table will solve for you. You just need to know how to interpret. So we use the rule of thumb. So if the t value is greater than 2, okay, the value, it means that the variable is significant at 5%. It means there's an effect. If it's more than what? 2 at 5%, it means that the value is significant. So when we have an absolute value, it means that we're going to ignore what? Whether it's negative or it's positive. So let me help you understand how we interpret the significance of the values there. So in this case here, um, for instance, where you have a coefficient of negative 3,500 and the standard error is what? 702. So how do you find the t? The t is a coefficient of the standard error. So this one divided by that, but we get 5.11. So we're going to be comparing this one against a 2. This is standard value. So is 2 more than this? Yes. By standard, we mean ignore the signs. Okay? Um, so if we are dividing this and that, so if the t value we're going to get is greater than 2, so if this 5 more than 2, yes, so you say this is significant. All right? If we found negative 1.11 is smaller than 2, it's smaller than 2, then we can say it is not significant. So we go now to interpreting the intercept. Now, the intercept is simply the cutting point. So we can have a sign of the intercept. So a positive means it increases as the outcome increases. If it's a negative, it decreases as the outcome decreases. So the significance, we use the t-test to see its importance. So our economic interpretation helps us to explain the result in real life. So if you have a negative on price elasticity, for instance, it means that if the price goes up, the quantity demanded goes down. If we have a positive cross price elasticity, we should understand by this stage that we are looking at what? We are looking at substitute good. If we have a negative cross price elasticity, it means that we have a complementary good. So we need to know the significance of that combined. Then also we need to understand the R squared. What did I say about the R squared? It means the coefficient of what? Determination. The R squared is the coefficient of determination. So it tells you how much the change in the dependent variable is explained by a model. So it ranges between 0 and 1. If it's closer to 1, it's a better model, it's higher. For instance, 0.93. It means 93% of the model of the dependent variable is explained by the independent variable. So this means that 93% of the variation in demand is strong. Okay. Then we also look at the overall F table. What does it mean? So I'm just trying to explain each of them one by one so that as we get to explain or see the table, we understand what we're talking about. So the F table tells us about all the variables combined if they have a meaningful effect. So we compare the p-value at 5%. So if the p-value is less than, here we're dealing with the opposite, it's less than 0.05, it means the model is what? Is significant. So if we have 1%, 2%, 3%, 4.9%, it means it's a good thing. But if we found more than 5%, it means it's not reliable. For instance, we found 5.1% or 0.051, 0.606, all these more than 5, it means the entire model is not reliable. So here, if your F is 4.5 and the p-value is 0.04, so this value shows you that the model is significant because it's smaller than what? The level of significance, which is 5%. Are we together?
Yes, the following.
All right. Then we also need to understand price elasticity of demand. Price elasticity of demand shows you how sensitive demand is to prices. So the formula for price elasticity of demand is the coefficient of demand times the price and quantity itself. So price elasticity of demand is always negative. So in this case, a coefficient of price elasticity of demand, if it's this 3090 and the actual price is 7.5 and the quantity is 20,000, you calculate the elasticity of demand here, which is 1.35. So elasticity of demand ranges, okay? If you have between 0, we have -1, we have -2. So any numbers between what? 0 and 1, price elasticity is inelastic. What does it mean to be inelastic? Being sensitive. So you can manipulate you can increase prices anyhow without having to affect your demand so much. At 1, it is unit elastic. If it's more than 1, it is elastic. So any values that are more than 1 are elastic, they're sensitive, so you don't need to play around with the prices anyhow. So -1.35 means demand is elastic. So we use on price elasticity coefficient and that. So the interpretation of that is that it is elastic. Okay. So now uh, let's go to the question now here. So we've been given the following um, table. So we're asked which of the explanatory variables are statistically significant. Okay, so when we analyze this table properly, we want to see the aspect of significance. So we use the t-value. Remember, the t-value simply says we divide what? The coefficient over the standard error. So we're going to look at these values individually. Okay, the coefficient over standard error. So we'll be dividing this by that, this by that. You manually need to divide and calculate to see what the values are. Okay, and you compare them to the value of what? If they're more than 2. So we'll start with the um, on price. On price elasticity, we are dividing 3,500 divided by 702. We're going to get 5.11. Is it more than 1? More than 2? Yes, so it's significant. Competitor's price, 4,000 over 800. What are we getting? 4.7. Is it more than is it more than 2? Yes. About 777 divided by 6, 6. Is it more than 2? Yes. The population 0.4 minus 0.3. Is it more than 2? No. So population is not significant. Okay. So this is how the first part is supposed to be answered to measure the significance. So of these ones, they just dividing this divided by that, this by that. So we discovered that the only part which is not significant is population. Are we together? Are we following? Is that clear?
Yes. It is.
Then part B, how much of the total variation in drink sales does the regression model explain? So here we want to calculate what? We want to calculate the R squared. So how much of the total model does this model explain? We'll check for R squared. So the R squared is where? Here. So how much is that? 93%, right? Are we together?
Yes.
Yes, then the next part is asking us to explain, um, compute the price elasticity of demand for drinks at the firm's mean price is what? 7.5, and the weekly quantity is what? 2000. Remember, elasticity of demand we said is what? The coefficient in the actual price over the quantities. Remember, yeah? So to calculate that, we set the coefficient, the actual price over quantity. What is the coefficient there?
0.04.
The actual coefficient, the general coefficient of here, the constant. The
For
coefficient for price.
45.
For price is what? Is
Negative
what?
4.
Negative 3,500, right?
35.
And the actual price is what?
Mm.
75 over 2,000, all right? So what do we get? When you calculate that, you're going to find your um, price elasticity of demand calculated as follows. So we're going to have the overall, which is 3,000, the actual price 7.5%. So we're going to find negative 1.35. So here we're going to comment that elasticity is what? Elastic. Are we together? Demand is elastic.
Mm.
All right. Then also we go to explaining the overall regression equation. That is it statistically significant at 1%? Is it statistically significant at 1%? So what did we say we do here to look at the overall? We use the F. Okay. So the p-value. What was our p-value? Our p-value is 1%. So anything if it's less than 1%, when given 1%, it will be significant. If it's more than 1%, it will be insignificant. So let's look for the p-value. What's the p-value? The p-value is 0.04. You multiply by 100 if you want. So 0.04 times 100 is 4%. So if it's more than this, it's not significant. So at 1%, is it significant? No. But if it was 5%, would it have been significant? Yes. Are we together? Are we
Yes.
together? You remember what I had explained, right?
Yes.
Yeah. So
Mm.
I hope it's making sense. So you needed some background information to understand
Yes. Getting
what's
there.
happening. Yeah. So the other question is, um, how appropriate is the estimated equation in terms of economic criterion? How appropriate is the estimated equation in terms of economic criterion? So economic interpretation. So let's start with what I explained in terms of the overall significance at 5%. Is it significant? We said it is not. Why? Because the 1%, the 4% is more than the 1%. But if it was at 5%, we would say it is significant. So here it is not significant. In the economic interpretation, on price elasticity is a negative. It shows that there's a negative relationship, meaning when we increase price, quantity demanded. All right, that is economic interpretation. It is inelastic. It is elastic. We found 1.3, so meaning any slight increase will significantly cause an increase in what? In quantity demanded. Then competitors' elasticity, um, we can check it here on the variable here. So competitors' elasticity, if it's a positive, we say these are what? Substitute goods. Income is also positive. It means it's a normal good. All right. So the significance of these ones are that for competitors' prices, if you get a positive, it means that these are substitute goods. So meaning consumers will switch this product when the price goes up. Then the income is positive, so meaning that is a normal good. So the demand will increase as income goes up. Then population, it is insignificant. We said it's one of the insignificant, so it means it doesn't add value to the model. It is not something that is very what? Cardinal to consider. It is not a significant what? Um, um, economic variable that we are yet to consider. Are we together? All right. So thank you so much for your time.